Hello everyone, welcome to this new video, and this video is all about Compute Engine. So Compute Engine is a service as an infrastructure, I would say, that is provided by GCP, and its simple terms, it's a virtual machine running on Google infrastructure. So virtual machines, as we all know, it's a virtual desktop or virtual operating system working on a real machine that allows you to run your different workloads. So let me explain in this way. So if you guys remember, whenever we have, let's say we have window machine, and we have to run a Linux on our window machine. So the solution was related to VirtualBox. So we install that software, and in that software we install our Linux. So this is what we call as virtual machine. The same concept is here as well, but at a large scale, where you have a machine running in Google, and that machine has virtual machines installed on it that allows us to run different kind of operations on that. So virtual machines actually gives us very much flexibility that allows you to choose uh, kind of different kind of combination, I would say. So let's say I have one requirement where I don't need such hard computation, or requires less memory, and also something I would say means not that complex. So Compute Agents gives us the opportunity to customize our own virtual machine, and then we can go and do the SSH, or any other way you can go and deploy your application, and you can serve that application to your customers. So Compute Engine is a like a virtual machine running in Google infrastructure. So there are many other features that are very important as per the exam point of view. These are the list of some features that are important that we should understand. So let's start with the first feature that Compute Agent provides is preemptible VMs. These are short-lived VMs that are used to deploy such works that are not so important, and because preemptive VMs are not long-running VMs, that they can easily be destroyed whenever infrastructure requires more VMs. These VMs are automatically destroyed, and those VMs are allocated to resource allocated to new VMs. Then it provides you the support for GPUs and TPUs. Maybe you have a requirement of running a artificial intelligence or any heavy model, then you can utilize GPUs. This There are two kind of memory storage it has. The one is SSD, and then the persistent. This local SSDs are kind of devices attached to the virtual machine itself, so it's very fast. But the problem is, like, once the VM is gone, maybe let's say your VM has stopped running, and once it's again starts, then your data will be lost because it's a local SSD. But the solution for this is the persistent disk. Like, it's a external storage that is attached by network to your virtual machines. Like, it allows you to preserve your data even though your virtual machines gets down. And now when we talk about Compute Engine virtual machines, then there are two kind of solutions that can be used to deploy your workloads on Compute Engine. One is managed instance group, and other one is unmanaged instance group. So managed instance groups are like, if you are running multiple VMs, let's say 50 to 60 VMs with same configuration, then you can use a managed instance group. But let's say you have different kind of requirements, different groups of virtual machines with different configurations, then those are known as unmanaged instance groups. So why we use managed instance groups? Look, there are possibilities, like you have to run multiple replicas. So how will you do that? So in that scenario, managed instance groups come to your rescue, where you define your maybe template, maybe image, maybe any other solution that can automatically pick that that image, that template, and creates the copies of that virtual machines whenever it's required, maybe for load balancing, maybe for more processing, whatever the solution, whatever the scenario is. Managed instance group are very helpful in that scenarios. So this is one, but unmanaged instance groups are also a type of solution, but that is kind of a different solution where each virtual machine is running at its own configuration. Okay, so there is one more question that comes often. I mean, that's not important, but still it's important because it's about the migrations of VMs. Let's say there's a day when your VM is going to for maintenance. Then what will happen? So GCP provides you the ability of live migrations that allow you to preserve your data, preserve your configurations, and no downtime will happen. So it's a configuration you have to choose while creating a virtual machine. And then we have sustained use discounts. That is kind of marketing thing, I would say, but it's used to reduce your bills while running compute engines. So it's a basic about compute engine. Now we talk about how it's deployed, where it's deployed. So as we know, GCP resources are deployed in regions and then in zones. So these configurations are done just to provide more resilience, more availability, and make the solution in fault tolerant. So you can deploy your VMs in multi-zone regions or in any configuration that suits you. And one thing is, like I mentioned while explaining the managed instance groups, like we can use images to make copies of your VMs. So you can use VMs to create virtual machines all around the globe, and this helps you to auto configuration, auto deployment of your virtual machines. You don't have to worry about how it will deployed in different regions. It can be done easily using the VM images. And also you can provide your IAM roles that helps you to restrict the access to VMs, maybe restrict the access to how it will be accessed, how it will be used by different resources in organization. So these are some very important considerations can be taken while creating a virtual machines, or I would say compute engine. Now there are two most important concept is of shielded VMs and confidential VMs. So confidential VMs are not, I mean, that important, but shielded VM is very important because it is used in those scenarios when you have to prevent your VM hardware, software, and core operating system in such a way that no hacking, no any kind of malware attack or anything can happen to it. So we use basically shielded VMs, and that helps you to prevent your solution, your infrastructure to the to the potential threats of rootkits or bootkits. So these are the very important points, very important configuration features of compute engine that you should know. So I think that I have explained quickly. Maybe I have missed something. So if I have missed something, you can uh, chat that, or you can add in a comment. So I will try to create some other videos so I can cover those parts as well. Let's talk about the use cases of compute engine. So as we know, compute engines are used to run your applications. It could be any application, maybe .NET, Java, uh, Node.js, C, and it can run any because it's a machine, and your machine can run anything. So it can be used to create web services, backend. Maybe you can run your database on it. You can run models on it. Maybe you can if you have suppose very heavy requirement of rendering a video processing and your laptop doesn't support it, you can use the virtual machine as your machine, not for any kind of deployment or running an web application or software. You can use it to run your own machines, and then where you can do all the kind of heavy processing on it. So this is the common use cases of compute engines. And then there is lift and shifting. So let me talk about lift and shift. So there are migration techniques that is very, there are many migration techniques available in the industry. One is a lift and shift, that is very easy, very helpful to migrate a very legacy application to the cloud. So what happens in lift and shift? It's about, first of all, you don't have to worry about changing anything related to your application. You just have to lift and shift your application to the compute engine, I mean a Google environment. So the best suited service is compute engine, because it's a machine, it can run the same way it's running in your local machine or your premises. So this kind of migrations can be done using the compute engines. So that's one more use case that is different than other use cases. I think this is all for the theoretical part of compute engine in this video. For next video, we will see a demo for our compute engine, where we will try to create a compute engine and host a website over there. So thanks for watching this video. Thank you so much.